Foundation Models for Embodied Decision-Making Agents, Part 22. It's been a while that we discussed the foundation models for robotics theme. To some extent, I think there hasn't been a lot of new stuff, but it's also kind of almost becoming, it's not even that special anymore. In other words, I think the merging of ideas between what's going on in the NLP space and what's going on in the robotics space is actually really astonishing. So I want to use Sergey's talk that he gave recently at Foxglove, which is I don't know, it's some sort of conference. I think it's a company, doesn't matter. Links in the show note. So lots of speeches in that particular conference. It's about robotics. It's about, I think the conference is called Actuate. So again, I'm not familiar with it. Apologize, but worth listening to. Definitely check it out. So this particular talk, keynote by Sergey, talks about foundation model for robotics. So this is actually what they're trying to do. So this is not that. That's why I think what we started about a year ago, foundation models for robotics, for embodied decision-making agents, was an idea. It was sort of a hope or even a concept that we could have the same idea that we have in natural language processing, and we could move it to the robotic space. And I think a year later, this is happening, and that's why we also haven't really had many episodes in the last 6 months talking about this, because a lot of the stuff that we talked about is already sort of embedding the idea. So this particular talk by Sergey is just an explicit reformulation of the concept, and of course an explanation for what is going on. So I think I want to really focus on two things here. One is a little bit more technical, and then the other is what the bigger implications are. This is not even on podcast. It's November 25th, 2024. This is Krim Delco for the day. The fund is down 7%. The market's up 30 basis points. For the year, we're up 61.6%. The market's up 24.9%. We're outperforming by 35.7%. Foundation models for robotics. This is a presentation that Sergey gave in lieu of his company, Pi Physical Intelligence, that is actually attempting to do foundation models for robotics. And now let me walk a little bit through the logic of what are we actually talking about here. So let's step back and look at what happened in the natural language processing space, right? We had the idea started with, let's say, reading handwritten language, which was one of the first projects, if not the first project, where computer vision was supposed to be used by the U.S. Post Office to read addresses. And then we go from there and we start developing a natural language processing sort of domain. We have things like Alexa, which supposedly was really good at understanding what people want. We have chatbots. We have self-correction, grammar correction, things along those lines. And then we have ChatGPT coming on the scene in November 22 and sort of changing everything, because now we have a foundation model. We have a generalist model that was trained on a lot of different types of data, which is able to generalize across different applications. So we're trained on Shakespeare, we're trained on marketing material, we're trained on Twitter, we're trained on all kinds of different text. It's a generalist model using attention mechanisms and things like that, transformer-based models that have a pre-trained version and then a fine-tuned version. And that really allows this amazing explosion of possibilities based on the foundation. That's why it's called a foundation model. That also was actually a discussion last year in Europe when actually it was Percy Liang who kind of had to explain to the world why the West Coast calls it foundation models when everybody else calls it large language models. Well, it's a foundation because you can now build software on top of it. You can build tasks on top of it. You can have these models as operating systems for other larger systems. And that's exactly where the robotics space kicks in. Now let's look at what robotics is doing. what Sergey and his collaborators are doing. Papers in the show notes. One of the papers, which I think is really interesting, but there's many other things that have been written about this. But the OpenBLA paper really, I think, explains really well what's going on. OpenBLA stands for Open Vision Language Action Model. So let's focus on the Vision Language Action Model. It's the same concept like the large language model. It's just vision, language, action. So we have a vision, we transform it into language, and we predict an action. So that's what VLA means. And open, it's an open source model. And what they're doing is collect data from different embodiments. So different, if you think about it this way, the robot world is really sort of a balkanized world where every lab has its own type of robot with its own type of tasks and its own type of goals that they want to achieve. Even last year, I mean, we're only talking 12, not even 12 months ago in Europe. I spoke with certain people, and they told me that the robotics community is still sort of entangled in this. Let me just solve, hammering a nail. Let me solve picking up a bottle. Let me solve folding clothes. It was balkanized in that sense. And what Sergey and his friends did is let's get all this data and feed it into one large vision language action model and train the model, and then see whether these tasks can be fulfilled with this new model better, or at least as good as when the tasks were trained specifically. And the answer is they were not just as good, they were better. So you were better with a generalized model trained on cross-embodied data than the specialized models trained on specific embodiments. So this is, I think, the biggest, in my opinion, really the biggest breakthrough. And then another thing that we spoke about a lot is, of course, also the transfer learning from navigation to manipulation and back and forth, which led us, and this was the big revelation at CVPR this year in May, that navigation and manipulation are essentially the same types of problems. So this is what Sergey's presentation is all about. I think I don't want to go deeper here in the technicalities, because for us, it's really important here at Orange Capital Partners to understand where the science is going and what the potential technological implications are of this, in particular for Optimus, but also for competition. And what OpenBLA is also trying to do, which is really important, is they're trying to commoditize the space. So they're trying to bring in open cross-embodiment onto commodity hardware. That's important. And they also are bringing in things like LoRa, so low-rank solutions for compute, which just means that you can sort of save yourself a lot of the compute and still perform pretty well. Again, there's a lot of that work has been discussed at the MLSys conference this year. How can we have more efficient compute? How can we have more energy efficient, cost efficient, and less low latency compute? And those are also some of the problems that this project is trying to solve, and that generally physical intelligence is trying to solve, the company that Sergey has co-founded with other people. So to summarize this presentation by Sergey Levine, I think it's a foundational presentation. Foundation Models for Robotics. It's part of our series, Foundation Models for Embodied Decision-Making Agents. And I think it's a nice conclusion maybe for the year. We're still a month away from the year end, but I think we can sort of wrap up 2024 in the robotics space as the year when the large language model, foundation model idea was accepted by the robotics community and implemented. And this is a great example of how that has been done. Thank you.